Hey, Jonathan here at Colfax Math. This channel is the applications of math and all things math. Today I'm going to talk about radian measure, comparing it to degrees. This is a really big idea in both math and science, and it's really cool as well. And there's a few pieces to it, and let me run through those right now. So let me start with degrees. Degrees is a unit measure. You can measure an angle in degrees. It's usually a central angle off of the circle. The notation for the measure of an angle in degrees is that little circle afterwards. And the full rotation is 360 degrees. So a half circle is 180 degrees, a quarter 90, and a 3/4 circle 270 degrees. I could cut those in half to get 45, 135, 225, 315. I could split into eighths. I could split it into 6 or 12ths, and those are degree measure. The Greek letter for measure of an angle is theta, and there's no way to tell if it's radian or degrees except for by the units that are labeled on there. So if you see this, when there's no notation of units, it has to be radians. When you see this, it has to be degrees. So radians are actually unitless. So when you see theta equals 20 and there's no notation of units, it is implied that there are no units and it's radians. Okay, so that's the first way to figure out the difference between a degree and a radian. The idea that radians are actually unitless is what makes them so useful, because then you could take this math and apply it to any real world application problem. Okay, so what is a radian? A radian is a measure of radiuses. So if this is my radius here, and I call this radius r, and I were to measure an arc length right here, when that arc length is the exact same length as the radius, I could also call that r. Then I could measure this arc length in terms of radiuses, and it would be 1 radius long. Let's say this arc length was even longer, like this. Like, let's say, I don't know, this is 2 units long. My radius is 1 unit, say. I want to figure out what this arc length is in terms of radiuses. That arc length would be equal to 2 divided by 1, or 2 radiuses. So I could talk about that arc length being 2 radiuses long. Or that arc length could be 3 radiuses long, or 4 radiuses long. So a radian is a way to measure arc lengths in terms of the radius. So let's go back a step and explain this another way. I know the circumference of a circle is equal to 2 pi r, or diameter times pi. Right? So now, if my circumference is in inches, say, and I have 2 pi r, r would also be in inches, my radius would be in inches, I could divide both sides of this equation by 2r in inches, 2r in inches, right? Then I could see that my 2's would cancel, my radiuses would cancel, my inches would cancel, and over here on this side my inches cancel, and I could see that pi is a ratio of circumference to 2r, and there are no units attached to pi because my units have canceled out here, and that's why radians are unitless. Okay, it's a big idea, and the whole point of these radians being unitless is that you can use it in a lot of different scenarios. When, if you're measuring an electrical wave, it's not measured in degrees. It might be in time, and time isn't degrees, so that's why you use units of radians, so that you could attach seconds or whatever you want to it. So remember, pi is not a variable, it's a number. It's a ratio of circumference to diameter, or to radius. My units cancel and pi is unitless. All right, let's go over a few problems first. So if all the way around the circle is 360 degrees, in the unit circle, when my radius is 1, the circumference would be 2 pi r. Radius is 1, so all the way around would be 2 pi. Halfway around would be pi. I'd want to cut that in half. So if this is 2 pi pi, this would be 1/2 pi, 1 pi, 1.5 pi, 3 pi over 2. So these are exact value measures in radians, and in black these are exact value in degrees, but they're equivalents. The other thing about radians is it could be used to measure an arc length or an angle contained within. So that's kind of a cool part of it as well. Okay, let me turn the page here. So let's just do some conversions from degrees to radians. So if I have 30 degrees and I want it to be into radians, I'm only writing radians as a placeholder. I don't actually have to write radians, because if nothing's written, it's radians. So it's a unit conversion. Well, if I know right here that 360 and 2 pi are equivalents, I know that 2 pi and 360 are the exact same thing, right? So they're the same thing. So this has the same weight as this, so this is equal to 1. Or I could reduce this, because this is equal to 2 times pi divided by 360 is 2 times 180. So the 2's cancel and give me pi over 180. So this is my conversion unit to go from degrees to radians. So to go from degrees to radians, I use pi over 180. And to go from radians to degrees, I use the reciprocal, 180 over pi. Okay, so that's my conversion unit. So if I have 30 degrees, I want to go to radians. I have degrees to radians. I'm going to multiply by pi over 180. These things have the exact same value, the pi and the 180. So it's equal to 1. I'm multiplying by 1. My degrees cancel, and that's going to give me 30 pi over 180. But then I could reduce that as well, because 30 goes into 30 1 times, 30 goes into 180 6 times. So it's equal to pi over 6 radians. So 30 degrees is pi over 6 radians. Let's do another one here. Let's say I have 45 degrees, and I want to convert that into radians. I multiply by pi over 180 degrees. My degrees cancel. 45 goes into 180 4 times. So this gives me pi over 4. So that's my answer. It's in radians. I don't have to write radians again because it's unitless. I just write it as a placeholder. If it's degrees, I always have to have that circle. Okay, so now let's go the opposite way. Let's go from radians to degrees. So from radians to degrees, I multiply by a conversion factor of 180 degrees over pi. So if I have, say, pi over 4, and I want to convert that into radians, I multiply it by 180 over pi. So there's my radians. That's 180 degrees. I multiply by that conversion factor. My pi's cancel. 4 goes into here 1 time. 4 goes into here 45 times. So it gives me 45 degrees. Okay, let's say if I just had a radian measure of pi, I multiply by the same conversion factor, 180 degrees over pi. My pi's cancel, and it gives me 180 degrees. I have to write that unit down every time because now I'm in degrees. Okay, so that's how I convert from radians to degrees. Actually, why don't you do one really quick here? Let's say I have 3 pi over 4. If you want to pause the video and do that one, 3 pi over 4, convert that into degrees. Okay, so what you do, or hopefully what you did, is you multiply it by 180 degrees over pi. My pi's will cancel. 4 will go into 180 45 times. 45 times 3, right? 45 times 3 is 135 degrees. All right, why don't you try going the opposite way? So let's say you have 120 degrees. Go ahead and pause the video and convert that into radians. Okay, to convert that to radians, I multiply not by 180 over pi, but I want radians, so it's by pi over 180. Here my degrees cancel. And then I want to reduce this fraction, 120 pi over 180. 60 will go into here twice. 60 will go into here 3 times. It'll give me pi over 3. And no, I'm sorry, 2 pi. 2 pi over 3. And that's the equivalent of 120 degrees. Again, I don't need to write radians on here because it's implied it's in radians because radians are unitless. If I wrote radians on here, it's just kind of as a placeholder, but it's kind of redundant. Okay, so that's how you convert radians to degrees and back again. My last idea I want to put out on this here is the difference between exact value and approximate value. Okay, so exact value means there's no rounding errors at all. So the number pi is an exact value versus a decimal approximation. So an approximate value would be 3.14. So that's a decimal approximation of the number pi. Another example would be, say, the square root of 2. Not sure what that is, but I think it's 1.4. The decimal approximation of that is 1.414, or an exact value would be, say, 1/3 in fractional form. The decimal approximation of that would be 0.33 repeating. So exact values are always better answers because there's no rounding error, there are no significant digit issues with it. So whenever you could leave it as an exact value, you want to. So an exact value is without a calculator. Approximate value is with a calculator. And how all this kind of plays into exact approximate values, plays into degrees and radians, is, let me draw my unit circle here again. Remember, all the way around 360, halfway around is 180, 90, 270, or the radian equivalents. This would be pi, this would be pi over 2, this would be 3 pi over 2, and this would be 2 pi. So this is degrees. Oops, I forgot, very importantly, my degree notation. Right, I have to say that these things are degrees. So in black here, these are degrees, these are radians, these are exact values of radians. So I could call this 2 pi, or I could still be in radians and call it 3.14 times 2, 6.28. That's still a radian measure. It's just an approximate radian measure versus the exact value radian measure. So it could be 360 degrees. That's a different type of units. That's degrees. 2 pi is a radian. 6.28 is a radian. And the difference is exact versus approximate. So I could call this pi over 2 in radians or 1.57 radians, and that's my approximate value. And the way I got 1.57, I just used my calculator and took pi 3.14 and divided it by 2. So usually in most trig courses you should know the 30, 60, 90 triangles and their reference angles, and also the 45s. And maybe I'll do another video on that, but I'll just touch on it here. And I'm going to go in degrees first. Half of 90 is 45. That gives me, it's an isosceles right triangle. Yeah. And then this is my next 45. 90 and 45 is 135. 180 and 45 is 225. Plus 45, plus 45, plus 45. The equivalence in degrees, the equivalence in radians in exact value would be, I'm splitting this thing into 1, 2, 3, 4, 5, 6, 7, 8 into 8s. All the way around is 2 pi. So this is 1/8 of 2 pi. I don't know if that made sense. This is going to be 1/8 of 2 pi. And then 2 will go in here, and this will give me pi over 4. So I'm counting by quarters. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, right? 3 over 2 is 6/4. So 5/4, 6/4, 7/4. And then back to 8/4. 8/4 is 2 pi. So those are the radian exact value 45 reference angles. Okay, well I hope that helped explain the difference between degrees and radians. Hope that was useful. And then I think the next video I'll go over more about these exact values. Thanks for watching. If you liked it, hit subscribe. I'd like to hear your comments below. Thank you.